Let's start the new article, Gravitational Acceleration and Variations in it. So first of all, we will see the sub-article of this, acceleration due to gravity, and we will start this article by consider the definition of gravitational acceleration. So the acceleration produced in a body due to the gravitational force is called gravitational acceleration. So basically, if you consider the event of an apple falling from a tree towards the ground, then the body is achieving the acceleration due to the gravitational force. And for example, here I am consider the earth as a perfect sphere of uniform density, and so I can find out the acceleration due to Earth's gravity on different points. So this is our task to find out. So for that we can imagine the Earth is made up of innumerable concentric hollow spherical shells, and so that we can now have the acceleration due to gravity at different points. And now the particle which is outside the Earth is also outside all these cells, and this is very easy to understand because suppose this is the Earth and these are some hollow spherical shells inside it, or we can consider it in this way. So a particle which is outside the Earth is also outside this spherical shell and this spherical shell, and for all it is applicable, and hence to find out the gravitational force on the particle, we can consider the mass of every shell as concentrated mass at the center of the Earth. Therefore, to find out gravitational force on the particle, then the mass what we have to consider, so we will say that this is the mass of the spherical shell, and this mass we will consider as concentrated mass at the center of the Earth. So in order to consider the force on the particle, we can say this total mass is also concentrated towards the center of Earth. Now let's suppose something, the mass of the Earth is me, the radius is r subscript p, and the gravitational force of the Earth on the particle mass m is given by F is equal to G small m me divided by r square. And so, from Newton's second law of motion, I can write down the acceleration due to gravity is defined as G is equal to F over m is equal to G me over r square. So that is equation number 2. Now, for the particle which is on the surface of the Earth, we can write down is given by Re is equal to small r, and therefore I can rewrite equation 2 as G is equal to, or G subscript E is equal to G me over Re square. So this is our final equation for gravitational acceleration for the particle inside the surface of Earth, and this is acceleration due to gravity, and hence this universal gravitation constant is arriving. Now if we talk in terms of radius of the Earth, then here we have assumed that the Earth is spherical, but it is slightly bulked out and not completely spherical. And here the radius of Earth is 21 kilometer more than the radius of the poles, or radius at the pole. Hence the value of Ge is slightly more than that at equator. So the value of gravitation of the Earth at the surface is less than the value of gravitational acceleration at poles. But the variation in the value of Ge at different places on the Earth's surface is extremely small, and the value of Ge is found to be 9.8 meter per second square, and it is universal or semi-universal because small variations are coming out. We can calculate the value of Ge by substituting the value of mass of Earth, that is 6 into 10 to power 24 kg, and the radius of Earth Re is equal to 6400 kilometer. So you may substitute this value in this equation. G is equal to GME over R. So let's try to find out. Therefore, G is equal to 6.67 into 10 to power minus 11 into mass of Earth is 6 into 10 to power 24 divided by 6400 kilometers, and its square we needed over here. So 6400 into 6400. We may convert this kilogram in as it is, but this kilometer I can convert it into meter. So it is 10 to power 3 into 10 to power 3 again. So now first of all 6.67 into 6, 10 to minus 11 and 10 to power 24. So it is 10 to power 13 divided by 64 into 64 into 10 to power this 4 plus 6 is 10, that is equal to 6.67 into 6 by 64 into 64, in the numerator 10 to power 3 is 10, is equal to 14.02 divided by 4096 into 10 to power 3. Now if we divide 14.02 by 4096, we will get the values in the form of 0.0097 into 10 to power 3. So applying this 10 to power 3 to our value, so we will get around 9.7. And if we look at after 2 decimal points, then it is also 7. So it is 9.77 meter per second square. So I can generally write down the value as 9.8 meter per second square. And hence with this our article is over, and we will solve some examples regarding this theory.